In Stata, we can use the summarize command to find information about variables. It tells us potential outliers. Here's an example. The sample contains data on 32 firms' R&D expenditures as a percentage of sales, annual sales, and profits as a percentage of sales. We want to know whether the firm's size is positively related to the firm's R&D intensity. In Stata, we type summarize with the detail option to find the minimum and maximum values of a variable in the sample, along with the variables sample mean and median. We find that the largest firm has annual sales more than double those of the second largest firm and more than 10 times the sample average. The largest firm is an outlier in this sample. We can also plot the observations in a graph with the outcome variable on the y-axis and the key explanatory variable on the x-axis. The plots can help identify the possible outliers. The scatter command is for the graph in Stata. The graph confirms the largest firm is an outlier. It is advisable to report the OLS estimates with and without the outlier. With the outlier, the OLS estimate for the firm size is not statistically significant at any conventional level. However, without that outlier, the OLS estimate increases by more than twice in size and becomes statistically significant at the 5% level. The sample above demonstrates that ordinary least squares OLS estimators are sensitive to outliers. The OLS method minimizes the sum of squared residuals, meaning that outliers have disproportionate weight on the estimates. As a result, the outliers can significantly distort the OLS estimates. In addition, the R-squared from the model without the outlier is much higher than that with the outlier. We see that the fitted line without the outlier has a steeper slope and fits the data better.